Hey, so in today's story time with Mrs. Smith, we're going to read all about space. So this is a really giant book, so I'm going to do my best to kind of center it in the screen. Maybe actually it'd be better if I held it out here. And what I'm going to do is I'm going to focus on this is a large book, so I'm going to focus on our exploration of space as humans. And we'll talk a little bit about astronauts, and I'm hoping that at the end of this book, one of you will decide you wish to be an astronaut someday. Scoping out space. Space is so enormous that today's fastest rocket would take almost 100,000 years to reach the nearest star beyond our sun. So, to learn about the universe, astronomers use telescopes. Telescopes collect the light coming from the distant objects and magnifying it, allowing us to see distant planets, stars, and galaxies as if they were much closer to us, almost as good as hopping in a starship. The first telescopes, known as refractors, used a lens to collect light. Then, in 1671, Sir Isaac Newton invented the reflecting telescope, which used a mirror to collect light. Today, most observatories' telescopes are reflectors. The bigger the mirror, the more light it can collect, so the bigger telescopes can show us objects that are fainter and farther away. Many observatories are now building monster scopes that will use mirrors as wide as houses. Not all telescopes collect the kind of light that our eyes can see. Planets, stars, and galaxies also send out invisible waves, such as radio beams and X rays. In the past 50 years, astronomers have invented telescopes that can detect this invisible radiation. The air above us blocks some of the waves, so astronomers place infrared, ultraviolet, and X ray telescopes in orbit, high above our atmosphere. X ray telescopes in orbit these space telescopes have revealed strange objects, such as exploding galaxies, black holes, that no one knew existed. You don't need the Hubble Space Telescope to explore space. With nothing but your eyes, you can gaze at the stars and find ancient constellations, such as Orion the Hunter and Leo the Lion. You can see 5 of the planets, watch the moon go from crescent to full, or spot a streaking meteor. Binoculars show as much detail as Galileo saw through his first simple telescope. They let you follow the moons of Jupiter, admire the many stars of the Milky Way, or find the fuzzy Orion Nebula. A telescope reveals from Saturn's rings and Jupiter's clouds to the spiral arms of the Andromeda Galaxy. If you want to look through a telescope or just ask questions about the night sky, contact your local observatory, planetarium, or space center. The first observer. Upon whatever part of the Milky Way the spyglass is directed, a crowd of stars is presented that is quite beyond calculation. These words were written by Galileo Galilei, the first person to see the sky through a telescope. He announced his sensational discoveries in 1610. The greatest astonishment is this: I have observed 4 planets which have their orbits around Jupiter. These were moons of Jupiter, and they proved that not everything revolves around Earth. Galileo added, I give infinite thanks that I alone have been the first observer of many amazing things. What about blast off? While telescopes let astronomers take a look at distant galaxies, rockets allow people to explore nearby space. The first person to travel into space was the Soviet Union's Yuri Gagarin in 1961. The United States and the Soviet Union then raced to put a human on the moon. The space race ended in 1969 when an American, Neil Armstrong, stepped onto the lunar surface. To soar high enough to start orbiting Earth, a spacecraft needs speed. If it goes any slower than 17,000 miles per hour, the spacecraft will fall back to the ground. Only rocket-powered spacecraft travel fast enough to reach space. Most are made of several stages that drop off, leaving a light upper stage to reach orbit. In the future, rocket-powered spaceplanes will reach orbit with a single stage. The National Aeronautics and Space Administration, or NASA, now has 4 space shuttles. The space shuttles can orbit Earth but cannot travel any farther. The Saturn V rocket propelled people to the moon on Apollo missions, but the last Saturn V was launched in 1973. Future rockets will allow people to travel back to the moon and past it to Mars. Wild ride into space. A shuttle launch is unlike anything ever experienced on Earth, explains Commander Eileen Collins. You see smoke around the shuttle on liftoff, then bright flashes of light, like a lightning storm. For the next 8.5 minutes, you hear fire. You smell electrical components in dry air. You feel your back aching. After spending 4 hours lying vertical during countdown, then during the ascent, you are hurled into space faster and faster. Breathing is difficult, reaching and moving is difficult, but suddenly acceleration cuts off and you are in zero gravity. How about dogs in space? Belka and Strelka, 2 Russian dogs, were the first creatures to return to Earth after orbiting it. They flew around the Korabl Sputnik 2 in August of 1960, 8 months before cosmonaut Yuri boarded the Vostok 1 spacecraft and became the first person in space. How about working in space? Shuttle astronauts have only a little time to enjoy the view of Earth below while they're in space. There's always work to do. They conduct long, complicated experiments, testing how zero gravity affects people, or how to make new materials such as ultra-pure crystals or medicines. On some missions, astronauts release satellites for observing Earth, the Sun, or the stars. Space work can also involve an extravehicular activity, or EVA. In other words, a spacewalk to repair satellites or assemble space station parts. Flights on a space shuttle last only a week or two, but cosmonauts and astronauts can spend months on a space station. Here they conduct much longer experiments. Life on a space station can be draining. The lack of gravity affects the flow of blood and wastes away muscles and weakens bones. Space station residents must exercise for hours every day to keep their bodies strong. Along with space shuttles and space stations, hundreds of satellites are working in space. Some were put into orbit by space shuttles, but most were lofted into space by rockets. Satellites make it possible to send TV pictures around the world instantly, to navigate ships across the ocean, or to predict the weather days in advance. We now depend on these ears and eyes in the sky. How about some flying food? Some food on the shuttle is ready to eat, and some is like dehydrated camping food. You just need to add water. A typical day's menu includes a breakfast of orange drink, scrambled eggs and a sweet roll, a lunch of soup, sandwich, banana, and cookies, and a dinner of beefsteak, broccoli, pudding, and cocoa. Here, Michael Baker grabs a bite of lunch, a free-floating peanut butter and jelly sandwich. How about a day in space? In 1998, Australian-born Andrew Thomas spent 5 months on Mir, the Russian space station. Although we see the sun rise 16 times a day, explained Thomas, we get up at 8:30 a.m. Moscow time. To wash, we can't splash water because it would float everywhere, so we use a damp washcloth. After breakfast, we work on our experiments. By 7 o'clock p.m., it's time for dinner. Then I watch the world go by out my window. We are in bed by 11 o'clock p.m. in bags that we tie to the wall. How about that's amazing? During weightlessness, the vertebrae of the spine spread apart. Astronauts grow 1 to 2 inches taller during spaceflight, and when they return to Earth, astronauts shrink back to pre-flight size. Space toilets can't use water to flush, so they use air. They are like vacuum cleaners that you sit on. Okay. So what happens if the people can't go there? Most planets, comets, and asteroids are too far away to visit in person, as of yet, but we still want to learn more about them. Because it would be too dangerous and expensive to send astronauts, we send remote-controlled robots, probes, instead. Most of our knowledge about the planets has come from these robots, which first visited Venus and Mars in the 1960s. Some probes orbit a planet. Magellan orbited Venus. A few, such as the Galileo probe at Jupiter, enter the planet's atmosphere, while probes like the Mars Pathfinder actually land on the planet. Others fly past the planet. Voyager studied Jupiter, Saturn, Uranus, and Neptune on a flyby. While probes are zooming past a planet, they can get a boost in speed from its gravity and then fly on toward a more distant planet. Using this slingshot method, we now have sent probes to every planet in the solar system except tiny dwarf planet Pluto. Robot probes can also explore other objects in the solar system. Future probes are expected to land on comets, hop across an asteroid, and zoom through the hot atmosphere of the sun. So far, no robot probe has returned to Earth. Instead, probes send their digital pictures and data to Earth as radio waves, and the signals are picked up by giant radio telescopes. In the future, though, some probes will carry samples from Mars, comets, and asteroids back to Earth. Okay, that's it for today. We'll read more about this for next week during Space Week number 2, and perhaps even a little bit tomorrow. I hope you've enjoyed.